Hi guys, today we will be discussing problem number 1458 in Leetcode, max dot product of two subsequences. So we will be given two integer arrays, nums1 and nums2. We need to find the maximum dot product between subsequences of two arrays. Also, it is mentioned that the subsequence should be non-empty. So we need to return at least one length subsequence. So this is some edge case that we need to handle. So what is dot product? It is also known as the scalar product. So dot product of two arrays is the sum of corresponding elements in the array. So mathematically we can define it as, so if we have two arrays A comma B, so dot product is the sum of all the corresponding elements from I equal to 0 to n minus 1, n being length of the array. So sum of all the corresponding elements. So this is the dot product. So let's take some example and understand. So if we uh, so if we have two elements, right? If we have, let's say, let's take two arrays, 1, 2, 3, and second array is 2, 4, and 5. So the dot product of these two arrays is dot product equal to 1 star 2 plus 2 star 4 plus 3 star 5. So this is the dot product, which is 2 plus 8 plus 15, which is 25. So yeah, this is the dot product. So yeah. So now what is subsequence? So we need to get our two subsequences from these nums1 and nums2. One from each, and that using those two subsequences, we need to calculate the dot product, and we need to ensure that this dot product is maximum. So what is subsequence? So subsequence is the sequence of elements in the array by deleting some of the elements, and we need to maintain the order, right? So so let's take one example of array. Let's say 1, 2, 3, 4. So for this array, the possible subsequences could be 1 comma 2 or 2 comma 3 or 1 comma 3 comma 4, or the complete array itself, 1, 2, 3, and 4. So yeah, we can delete any number of elements. We can delete nothing also, but this order should be maintained. So here 1 comma 2, 1 comes before 2, and 2 comma 3, 1, 3, 4. So this order, these 1, 3, 4 elements order in the main array is also same, 1, 3, 4. So this is known as subsequent. So we need to create one subsequence from nums1 and one from nums2, so that their dot product will be maximum. So subsequence for any array of length n. So there will be total of 2 power n subsequences, right? Y to power n. So if there is any array, let's say 1, 2, 3, 4. So we can include this element or not. So there are two possibilities. We can include this or not, and two possibilities here. There is an option to include this or not, and two possibilities here. So it will be 2 power 4. So similarly, if array size is n, then the number of possible subsequences will be 2 power of n. So now we are clear what subsequence is and what dot product is. So let's try to let's take this given example and try to calculate max dot product, and see what is the process here. So we have two arrays, 1, 2, 1, minus 2, and 5. And the other one is 3, 0, and minus 6. So we need to get two subsequences, one from this, one from this, one from this, and the dot product of the obtained subsequences should be maximum. So let's say, let's start at this particular index, and let's start at 0th index for this variable. And so here we have an option to include both of these in the resulting subsequence, and when we can exclude this. So this is one possibility. So if we include these two, then the resulting answer will be 2 star 3, and see max dot product of these elements. So let's say somehow we calculated the answer for these elements. So then the resulting answer will be the product of these two numbers if we want to include these two, and the result of the max dot product of the remaining subarray, this one and this one. So yeah. So let's solve it by using indices. So maximum of max dp dot product of from I plus 1 comma j plus 1. So so this represents, let me clear and write. Okay. So 301 minus 6. So here we want to include these two. So right, if we want to include in the result, we need to add this multiplication, right? So 2 plus 3, and let's say somehow we calculated answer for this part, right, where from I equal to 1, from j equal to 1. So dot product of, so how we calculate the solution for the the smaller subproblem, that we'll discuss. But let's say if we have the solution for this, then the result will be a product of these two, 2 star 3 plus dot product starting from I plus 1th index and j plus 1th index. Right. If we know the answer for this, then we can simply include these two, and the dot product, whatever the answer we get from this problem, and we can add these two, and the result will be that. So there is one more option. Suppose if you don't want to include this element in the array, but if you want to include this, then we don't we should not add this product 2 star 3, but then the solution will be dot product of dot product of we don't want to include this, so we will move forward. So I plus 1, but you want to include this element, so it will be j. So if you know the solution, if you know the solution of this, then it's good. We can just simply ignore this 2, and then resulting we can return. And there is one more case, if you want to include this, and if you don't want to include 3, then the solution will be dot product of I. So these are three possible states at any point of time. So these are three. So since we want the maximum possible value, we can return the max of these three. So this will be our answer. So this is the let me add this properly. Let me erase this. So instead of 2 comma 3, I'm just generalizing it for all the yeah, I'm just generalizing the recursive solution here. So instead of this 2 comma 3, it will be nums of let's let me erase this. Yeah, it will be first array, let's say array of let's represent it by a of I star b of j. So this is the recursive solution. So we need to calculate this and we need to get the problem. So yeah, if we do this, so there will be so many repetitive problems. So let's say if we are at 0 comma 0 first, so here we will try to, so if we want to include the elements, then we will try to calculate from 1 comma 1 index, and then if you do, and then add this the whatever present in here. I mean, for that basically you need the solution for 1 comma 1. And also if you are at 0 comma 0, if you don't want to include the ith position element, then you'll simply do this. And also the third possible outcome will be 0 comma 1, right? So here also there will be three possible solutions, which will be 2 comma 2 if you want to include this, and here if you don't want to include, uh, then it will be 1 comma 2 or 2 comma 1. Similarly 2 comma 1. So similarly here it will, if you want to include, it will be 2 comma 1 and so on for all three. So here if you see this 2 comma 1, this 2 comma 1, I mean there is a repetitive that we are calculating here. Also while calculating for 1 comma 1, we will be calculating 2 comma 1 solution, and also for calculating 1 0 we will need 2 1, and here also we will be calculating 2 comma 1. So if we once we calculate this solution for 2 comma 1, if we memorize this, then we can reuse the solution that we calculated, right? So using memorization, yeah, I mean we are basically not repeating the work that we have done already. So let's quickly see what will be the pseudocode for this, and then yeah, let's try to code it. So for this recursive solution, we need base case. So while doing that, if n reaches the length of the array, uh, yeah, let me write it instead of drawing. So if n is greater than or equal to n, right? I mean n being the length of the first array, or if I, even if index of the first array crosses the length, or index of the second crosses the length of the second array, then we don't have any solution, right? I mean it already crossed, so we can just simply return 0 from here. And second case, so if the if I comma j are valid, then we, I mean there are three cases. So case one will be including that number, so nums1 of I star nums2 of j, plus we'll need to solve it for I plus 1 comma j plus 1. So and case 2 will be, we don't want to include ith position number, so we will just simply solve for I plus 1 and j. We want to include this. And case 3 will be, need to solve, I mean we want to include ith number, but we don't want to include the jth number. So this is the case 3, and we need to return max of case 1, case 2, and case 3, right? So before returning, we will be initializing some memorization dp, and we will be initializing these values. So yeah, here mem of I comma j, we'll put it as, and we will store this value as max, and then max of these three. And yeah, I mean, before calculating this, we will check if this has already been calculated and we will return. So this is the pseudocode. So I mean, I've written it. Yeah, let's quickly code this solution, right? So let's initialize a memorization matrix, and this will have nums1 and so instead of passing these nums1 and nums2 to all the subsequent recursive functions, I'm just initializing these two in the class itself. So uh, it would be easier to write code here this way. So we will this dot nums1 equal to nums1, this dot equal to nums2, this dot equal to new int of nums1 dot length will create a 2D matrix. So dot length. So and then now we will need to return all. We are at 0th index from both of these two. Let's try to implement this. So it's all we will be getting two indices, the current position, the current state of the matrix. So here the base case, if this I is greater than or equal to nums1 dot length, so we don't have answer, we can return 0 because we don't have any elements here. We, so similarly, if j is greater than nums dot length, then return 0. So this is the base case, and if we already calculated if memorization of I comma j, if we calculated the solution for that particular I comma j, then we will simply return that. If not, let's solve it. So let's take three cases. The first case will be including, including both I and j. So nums1 of I star nums2 of j plus solve of I plus 1 comma j plus 1. So we have already included this, so we are moving forward. And then the case 2 will be, we don't want to include ith position, so we will just move ahead, solve of I plus 1 comma j, and then the case 3 will be solve of I comma j plus 1. So we okay. Memorize now before returning, we need to store this value, right? So math dot max of case 1, math dot max of um, case 3. Let's return this memorization of I comma j. So this should work, but we did not handle one edge case that is mentioned. So we need to return non-empty set. So let's say if we have an array where the elements the first array is all negative elements, and the second array, if the elements are all positive, then we will be returning 0 in that case, because all these cases will return 0. So so yeah, they have given this example 3 here in this case, right? So in this case, if so we need to handle this if there are all negative integers in one array and if all positive integers in the second array, then we need to calculate the minimum value in these two, and then we need to return that product from it, there itself without calculating all these three. Let's take one example, other than this -1 -1. So let's say if we have an example of -1 -2 -3 -4 and 2 3 5 4. So in this case we need to return ideally -1 comma 2, right? So we need to calculate the minimum value here. Minimum value, so this will be the maximum value in this array. So we need to calculate the maximum value because -1 is greater than uh, -2. So we need to calculate the maximum value in this array and product it with -1 and product it with the minimum value in this array and return the. So yeah, so this case we need to handle it separately. So let's see how we can do it. So when if all the numbers in this array are negative and one more array is positive, so yeah, let's first calculate the minimum and maximum values of all the array in of both the arrays, minimum value in first array and minimum value in second array. Similarly, maximum value in first array and maximum value in second array. So by that, we can decide if one particular array has all the negative numbers or not. So by using that, we can return from there. So let's write this H2S quickly. So int minimum value in first array equal to, let's initialize it to the dot max value, and then mint minimum value in second array, which will be equal to integer dot max value, and similarly int max value in first array equal to integer dot. I'm initializing this minimum value to maximum value and maximum value to initial to minimum value, so that whenever we came across the minimum value, we will update this. Int max second equal to integer dot int x or number in nums1 min first equal to f dot min of min first, no, and first equal to max dot max first, no. So similarly for second one, second will be equal to max. So here we're calculating the minimum and maximum values in there. So now if first, so max of first, max of first, if this is less than 0 and min of second, this is greater than 0, Then we need to return star. Similarly, if max second is less than 0 and min first is greater than 0, then we need to return max second star min first, right? So this we need to handle. It'll add some lines of code, but this we need to handle this edge case. Let's quickly try running this. This for my bad. That's bad. Let's open it. Yeah, so this is it. Yeah, thanks for watching.